Okay, so in this lesson, we're going to discuss a lot of the different ways of describing and representing colors in CSS. And up until now, if we go to the CSS that we've been writing, we've just been using simple elementary school colors like red and green and purple. And obviously those work okay, but they're not particularly nice shades. They're not nice colors in my opinion. And you'd probably never use them because most designers and most people making websites have a very specific color palette. Whether it's something that is following a brand's color, like a very specific shade of green for a brand, or if it's a color palette that a designer or someone has created, almost nobody uses just the plain default red or green or purple. With that said, there are quite a few built-in colors in CSS that have names. And in fact, there's probably more than you would think, and there are way more than most people ever remember. So there's things like cornflower blue or dark orchid, and there's, I think, 147 different colors. And this site here, which I've actually really never used, but I just want to show it to you, is a way to visualize all the different named colors in CSS. And of course, the problem with using these is still, it's only 147 colors. And you might want a color that's just like this gold color, but slightly lighter, or slightly darker, or slightly redder. And there's not going to be a perfect option for you. And then the other problem is that it's just hard to remember these names, like light slate gray. Nobody remembers that. So I really only use named colors like red, orange, purple, just for very quick debugging purposes to make sure something's working. I'll just turn it red and see if that works. And also just for educational purposes. But most people would never use these colors. So CSS provides a few different color systems that we can work with. And these are color systems, by the way, that exist outside of CSS. So if you have some familiarity with photography or printing, and you've worked with colors before, you may have encountered some of these. So the first one is something called hexadecimal. And before we talk about why it's called hexadecimal and what that means, let's just take a look at a few examples. So over here, the first thing we're doing is selecting all H1s and changing their text color to be black. The next thing we're doing is selecting all H2s, changing their color to be a shade of purple, and then selecting all H3s and changing them to be a shade of pink. So what you'll notice is that rather than having a word like red or purple, we now have this hash symbol, it's technically called an octothorpe, followed by 6 digits. So to get black, it's 6 zeros. To get purple, you'll notice it's numbers, but there's also a letter B in there. And lastly, to get this pinkish color, it's again numbers and letters, this time letter F. So what's happening here? I'm going to go ahead and open up some notes that I have. And we're going to do a really short math lesson. This is more just for, it's something I think is interesting, but it's also informative and will help you understand how hexadecimal works. So if we go back to middle school, when I was in school at least, we talked a lot about the decimal system and how, let's suppose I wanted to create a 3-digit number. We have our ones place, the tens place, and the hundreds place. So if I wanted a number, the largest 3-digit number I can create is 999. The smallest 3-digit number technically is 111 or 001. But the idea is that each place in our regular, base 10, which is what this means, base 10 decimal number system, I have 10 choices for every slot. I can do 0 through 9. So that's base 10. That's what we're used to working with. Our digits are 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. But there are other number systems. So you may have heard of binary before, and that's base 2. And so that means we only have 0 and 1 as our options. So if I wanted to build a 3-digit binary number, the largest one I can build is 111. That is not the same as 111. So this is not really the time to really go over how binary works, but you may see things like this in like CSI shows or any sort of show where they're trying to show you what hacking looks like, and they're totally wrong. But it is true that binary is a really, really important part of how computers work. So that's base 2. So we just have 2 choices, 0 or 1. So hexadecimal is base 16. So that means that we have 16 choices. And those choices go from 0 to 9. And then rather than going to 10, 11, 12, 13, 14, 15, those are two-digit numbers, which is problematic. Hexadecimal instead includes letters. So we have 0 through 9, and then A, B, C, D, E, F. So the largest hexadecimal number, three-digit number, would be F, F, F. And the smallest, 0, 0, 0. So it's just like any other number system, except we have 16 choices. And the reason that hexadecimal is used, rather than using just decimal to name a color, is that it gives us a lot more choices while keeping the names of our colors relatively short. So basically, hexadecimal is just taking colors and giving them numeric names. And if we use base 10, we only have 10 choices per digit, so we would need to use more digits. If we use binary, then we need to use a ton of digits to represent colors, like hundreds and hundreds of thousands of digits. So hexadecimal numbers are 6 digits long, starts with an octothorpe, and then 1 digit, 2, 3, 4, 5, 6. And the way that it works, it's not just random numbers. There's actually a little bit of a system. So the first two numbers correspond to how much red is in the color. The next two corresponds to how much green, and then the last two correspond to how much blue is in the color. So I'm going to go ahead and switch over to our CSS and show you what I mean. So let's just work with our H1 here. We have 3 H1s, and let's style them. So to use hexadecimal, all we do is type our octothorpe and then 6 digits. So let's start by defining a red color. And remember, the first two are red. So our first 2 digits, if we wanted full red, would be FF, because that's the highest number. And then everything else can be 0. So this is going to say turn red all the way up, no green and no blue. And if we do that, let's go ahead and open up our file. You'll see that our H1s are bright red. So let's go back and let's play with this a little bit. And now let's introduce a little bit of green. So let's give it 8. And you'll see we get this slight orange. And you might be wondering, how is green plus red orange? And the answer is that this is not the same color system that you're used to, like mixing paints, for instance. RGB works slightly different. And again, that's something for another video, but essentially, if we added up red, green, and blue all the way up, so full red, full green, and full blue, the resulting color is not like a brown or a black like you might expect. It's actually white. And this is actually how light works in the real world. If you could take 2 LED lights or 3 LED lights, a red, a green, and a blue, and combine them and shine them together, you would actually get white light. So that's how this color system works. Okay, so most of the time, you're actually not coming up with these colors from scratch. So it's not really, it's a nice skill, but you don't have to be able to identify this color as some sort of shade of purple or green or whatever it is. That's not really the skill. What you most often will do is have a color picker. And so let's say I want like a dark purple shade. There's all sorts of color pickers. There's some that are on your machine, depending on if you have a Mac or a PC. You can download one. Some of them are included. But we can also just go online. And if I want like a dark purple shade, I can just find this purple. Let's say this color here. And then I can just copy. I think that copied it. Nope. I can just copy. There it is. This color. And use that. Refresh, and we get a dark purple. So this is most often what you'll do. You'll have a color picker. Initially, you'll pick your colors, and then you just refer back to them. So it's not the most intuitive. It is nicer if it said something like dark eggplant, but then of course, that's not going to be as precise. That is just one shade of dark purple, and if I want to change it, I'm out of luck. So that's hexadecimal. The next color system we're going to talk about is RGB. So RGB works very similarly, except the syntax is slightly different. So RGB, there are 3 channels, just like with hexadecimal. There's red, green, and blue. And what's different is that RGB is still in base 10. So what we do, we have 3 different channels, red, green, and blue. And the syntax is color, colon, and then the word or the letters RGB, parentheses, and then the value of our red, the value of our green, and the value of our blue. And those range from 0 to 255. So in this case, we're saying all H1s are RGB where red is 0, green is all the way up, and blue is 0. And we get this, bright green. In this one, we're setting all H2s to be RGB where red is about halfway up, green is completely gone, and blue is about halfway up, and we get a nice purple. And in this one, we're setting all H3s to be mainly blue with a little green and even less red, and we get this shade of blue. So let's do a few examples. Let's go let's do a purple again. So we just type the word RGB, parentheses, and then we need our channels. So the first one, if we want a purple, we'll want some red. Let's do 68 red, 0 green, and this will be a bluer purple than a redder purple. So we'll do 100 blue, and we save that. And of course, it doesn't look like much of a change, but it did change slightly. So let's go ahead and now turn up the red quite a bit, 240, and you can see we get a pinkish purple. And if I introduce some green, and if I turn everything all the way up, just like before with hexadecimal, full red, green, and blue actually gives us white. And to get black, we want 0 for all 3 channels. So RGB is very similar to hexadecimal. The only difference is the syntax. So rather than writing out something like this, where we have 2 channels or 2 digits for red, 2 for green, and 2 for blue, instead we have 3 slots, and we just go from 0 to 255. So just another syntax. And one other syntax I want to talk about is RGBA. So RGBA works just like RGB, except there's one small twist, which is there's a 4th channel called alpha, which is how you can make colors transparent. So RGBA is great if you want to have one color that you are making more or less transparent. So the way that it works is the same exact syntax, except we write RGBA, and then we have 4 channels that we need to fill out. And the first 3, just like before, they range from 0 to 255. But the last channel, the alpha channel, ranges from 0 to 1. So I'll give you a few examples here. Here, we're setting all 3 to be the exact same color as far as the R, G, and B channels are concerned. So 11 red, 99 green, 150 blue. And then the 4th channel, we're changing the alpha. We're changing the transparency. So with full alpha, with everything all up, no transparency at all, we end up with this blue. When we set alpha to be 0.6, we get this much lighter and more transparent blue. And when we set it to be 0.2, we get this, which is barely there. So let's do another example. Let's do RGBA, and this time let's do a green. So 200 or so green and a little bit of blue. And then we need our alpha, and let's just start with 1. Refresh the page, and we get this green. So now let's do the same thing, but make it slightly paler. So let's do 0.8. I'm going to refresh, and you can see it got a little bit paler. Now let's be more drastic, down to 0.2. And you can see it gets a lot more transparent. So to summarize, we have the built-in colors, which most people don't use. We have hexadecimal, we have RGB, and then RGBA, where the A stands for alpha.